Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be looking at Wireguard right after this. So I've set up a couple of VPNs, or virtual machines, a VPN on the brain. I set up a couple of virtual machines today to be able to do this. Now I could do Docker and to do that, but I think what I'm going to do is just show two virtual machines, and then you can extrapolate from there how it would work on real world hardware. I just don't have hardware I can dedicate to this right now. Yeah, they're all busy and they're all waiting on stuff. So, yeah, my usual excuse. Please insert DJ's usual excuse. So, what do I got here for hardware? So, I'm going to dedicate about 2 gig of RAM, 2 processors, and about 20 gig of disk. You can see that down here. It's 20 gig of disk right here. I'm only going to define one network controller for this. That's all I need. Now, typically, you wouldn't do that, right? But because it's under VPN, a virtual machine, you can get away with a lot of sins. But you normally would have one of your Ethernet machine, one of your Ethernet devices dedicated to your management network. So same with the second one. They're basically identical, just different names. And then for what I'm actually going to use to run on them, let me get that up here. Let me clear this mess off. See, the cat's been walking on the screen. I'm going to actually run, let me do this. So I'm actually running 2004 as the operating system, and this is, of course, going to be the server variant of Ubuntu. And so, yeah, that's what I'm going to be doing. As far as WireGuard's concerned, you can go out here, it'll explain, kind of what's going on with it. Conceptually, it is a kernel level VPN. That's basically it. The drivers are inside the kernel. There's you just install the tools, and you're off to the races and ready to go. There is a DKMS package if you do not have a kernel that supports WireGuard to install it, but that's not what I'm going to be working with today. The 2004 version of Ubuntu already has the WireGuard installed in the kernel, so there's no need to do that. If you want to get into the in-depth part of the protocol, there's a white paper that you can get to from their homepage, and that is on wireguard.com. I'll leave a link in the show notes for all of this, and then you can go through and they talk about their endpoints and how their cryptography works, and a little bit about some of the protocols and also the optional pre-shared symmetrical key and what that does for you. Also, they talk about the timers and they talk about how it works with the kernel, and then they talk about performance and they compare it with OpenVPN and IPsec version 1 and 2, and then WireGuard, of course, at the bottom. The throughput on WireGuard is significantly faster according to their benchmarks. I'm not sure. Let's see. Did they specify what benchmark they used? Always suspicious when I see benchmarks that aren't documented. So, hey guys at WireGuard, if you're going to do this, you're going to show benchmarks, you need to tell us what you use to generate the data for that. Because we're going to come around behind you and we're going to validate that our results are similar to yours. Now, it probably won't be. They're using some older Intel hardware. I mean, these are, 2012 for this one. This one's maybe a year or two later. And that's of course, a mobile. I'm going to be using a mobile chip as well. My virtual machine is a 10th gen Intel Core i7, but it's the mobile version of it because it's inside of a NUC. Shouldn't be a big deal though, right? One thing that you will need with this is AES-NI support inside the kernel. So AES-NI, inside your chip. AES-NI is Intel's cryptographic accelerator. So yeah, it will help. I'm sure it will help. But let's look at kind of the quick start here a little bit. So there's two ways you can actually install and get this to work. The command line interface using the WG command set is meant to kind of stepwise go through and set it up and get it to go. And there's also this one where they're showing right here, this is the WP Quick, and this allows you to create a configuration file that you can then just recall so it comes up and it runs with the configurations already set up. So yeah, however way you want to do it is up to you. I'm going to be using the WG Quick today. I did set this up originally when I went through it manually doing these steps, and they work fine. So you shouldn't have any problem, provided you have actual kernel support for Wireguard. You shouldn't have any problem with it. What else can we talk about? Known limitations. So a couple things in the VPN video that I did. I talked about DPI a little bit and how it can be used to block access from a VPN. So yeah, it can detect it and it can block VPNs from running. So they don't concentrate on support for, kind of hiding themselves from DPI. It's a cat and mouse game, right? I see a DPI query or a probe, and then I mask myself to look like something else, but they don't do that. They are UDP protocol only, and I'm sure that's for performance reasons. So if you're expecting to do things like tunnel over TCP, that's not going to work. I think there's, I'm going to be using a TCP/IP protocol today to tunnel with Wireguard, and it does work, but it is kind of it's a tunnel through their tunnel, right? So anyway, they talk about the crypto and hardware acceleration. There are manufacturers that make hardware crypto accelerators. They are plug-in boards that go into your processing machine, usually as a PCI device. Sometimes they clip onto the end of the network, but they're designed to do hardware encryption and decryption of the packets or whatever data that you're giving it. And they are much faster than obviously a CPU would be, because you usually have some form of parallel processing in them to make them extremely quick. However, in all honesty, you don't see them quite as much as you used to. I'm sure that there are still entities that use it that are doing nothing but sending encrypted traffic over their network, that you will see hardware accelerators. But you don't see them as much as you used to, but I'm sure there's still places where they use them heavily. But anyway, they don't support hardware accelerated cryptographic hardware yet. But they're relying on the AES-NI, which is a form of hardware encryption because it's inside of your CPU. The other thing that they're talking about, the roaming mischief or man-in-the-middle. WireGuard does not do anything specific to block man-in-the-middle attacks. However, they do block because it's encrypted. So it's really of little use to that man-in-the-middle unless they get a hold of your keys. They get a hold of your keys, game over. They can decrypt and encrypt at will, right? So they could bring in the packet, decrypt it, store it off, re-encrypt it, and send it back out the other side. But yeah, not a simple thing to have to deal with. The other thing is they don't post quantum. That I don't think this is going to be unique to WireGuard. The last video I did was about a year ago, and I talked about the quantum computing's algorithms and the ability for them to decrypt cryptographic traffic. There are cryptographic standards that are being developed now. In fact, they've been in work for the last 3 years. But there are cryptographic standards that are being developed in order to defeat the quantum's ability to quickly and rapidly decrypt messages. So, but we're all in the same boat. WireGuard isn't unique in that regard, so not a big deal. Denial of service. WireGuard is kicking the can up the stairs. They're saying this isn't really for us to have to deal with. It's just something that your normal protocols within your network and your software should be able to handle, and we're not going to deal with it. So, with that, I guess let me just get this out of the way. And I don't think And there's the other one. Get the other one up too. And we'll go ahead and get started. So the first thing you'll want to do is to install. Now you'll want to check their website for the correct command and package name for your particular distribution. If you have a kernel within the last I don't know, year or so, you're probably fine for WireGuard. Maybe 5.4, 5.8 should be able to support it. I checked a this is a 5.4 and it's running on it just fine. But it'll tell me it's already installed, so I've already done it. And you'll want to repeat that obviously on both machines. Now this one, let's do it this way. So the IP address of this one is a DHCP address, not advised, right? All right. So, but my DHCP server will favor this address for the next 30 days. It's just the way it's configured. So, but yeah, eventually I will have problems and I'll have to go back in and change it to a static. So, and then this one is 115. So they're two numbers apart. So what do I do first? So the first thing I want to do is a WG gen key, and I want to redirect that to let's just send it to junk to start with. Now I have set, there's junk, so let's remove all that stuff. So I have set a UMask of 0027 and 0077. So that will then allow it to only be readable by me. If you have a UMask set to 027 and you attempt to run this command, well, it didn't say nothing, did it? Didn't care about that. I guess as long as it's not world writable. Let's try world writable. There. Now it's going to give me a warning that the UMask needs to be set up higher as a suggestion, but it will go ahead and generate it. But one thing I will tell you, you'll need to do this. Yep. Let's try it again. There we go. There, now I got it. And this will be my private key. To get my public key, I need to do a WG pub key. And I want to input junk and output my junk pub. Yeah, there. So there's my private key, there's my public key. Don't worry, I'm going to destroy this. So it's if you think you got me, you don't, because that'll be destroyed. But anyway, you'll do the same thing over here. Now I've already done these. I already have a private and a public key. I'll just get rid of junk because I'm done with that. So I already have a public and a private key. And then the next step would be to go ahead and set up my config file because I'm going to be using WG Quick. So let's look at what I have done here. If you want, I can put these on my, I can add these to my GitLab page if you are interested in using mine. Of course, now you'll have to change the private key and the public keys to match what you're doing. So a couple of things about this. So there are two segments in here, and the peer segment can repeat depending upon which one of these guys is going to be your server. So that is how you determine the server is the one that has the most peers. So interface is the address of the Wireguard VPN connection. So this will be the VPN connection. So I've assigned it to 10.0.0.1, gave it a 24 netmask. The private key is coming from the local host. As you can see here, the public key in the peer is coming from this one. It's coming from the other side. So make sure you don't make sure you don't put anything else after this, no space or anything after it, and make sure you have spaces in between. So because it doesn't know if that equal sign belongs to the key or if it's part of the assignment. And then I have the listen port. I'm defaulting it to 51820. If you don't pick one, it will by random, and then you'll have to go in and figure it out which one it chose before you set up your peer. So yeah, the allowed IPs, this has kind of a special connotation, which we'll talk about. I had to make some changes. There will be a firewall, a rule inserted that will block any other traffic other than 51820. So if you allow all IPs, world IPs, it will block. If you do specific, like if I were to just say only allow the 115, which would be the endpoint over there, or just make it 1.0, that's okay. I don't think it'll do anything as far as setting up the firewall rules to block. But there is a special thing that I had to do to get SSH to continue to work, and I will show you that. So, and then the endpoint is the opposite machine. So that should be this guy over here. And then this one, oops. Yeah, I know, I keep doing that, don't I? So, and this one will have its private key, the local private key for WG2, and the public key comes from this guy. That should be straightforward. Has the same allowed P and all that. But let me show you what I actually had to do. So, a couple things. First of all, if I look at the man page for Quick, it will talk about that, where to put the config file and where it defaults to. So it's going to look for it as under Etsy Wireguard interface. And so all you have to do is you can do a quick up and then just give it the interface name. You see that one is optional. So you can do that, and it will then look for the actual configuration file in Etsy Wireguard with the name of the interface, like this one would be WG1, this one would be WG2. And then it gives you some other information about some example configurations, like, for example, if you want to carry your DNS traffic across, you can do that so that your DNS servers are still working through the tunnel. The default is that they won't. it'll resolve the IP address, but it won't resolve the named address. And then there's some pre and post and pre-up and pre-down. The table controls allow you to route what protocols that are outside of its norm, like a TCP protocol, for example. In my case, SSH is what I'm going to have to add in there. And so they give you some examples that you can follow, like here's the DNS that you can add on, and there's a post up, post down if you want to do specifics. With this case, looks like it is building on the latest example attempt. Let's see if I can figure this out. Looks like it's rejecting traffic that is local. So in other words, it's only going to allow traffic through the tunnel. So yeah. Also, save config is used if you make any changes on the fly using the WG command. When you down or change state on the server, it will reload and rewrite. I think it says it will rewrite your config file. But the only way I would know that for sure would be to go test it, and I haven't. So, and then it gives an example if that config file is in a different path, and this one is assuming it's in Etsy Wireguard. So let's go look at what I have done here. So I've added a couple of things. I've added the table. I took their example 1, 2, 3, and then I just added a rule to add support for port 22 and assigned it to the table. And so when it comes up, it adds the rule to permit it, and when it comes down, it deletes that rule out of the protocol table. So There is also, I think that other one actually, that last example they showed was actually how to create a kill. There is a way to create a kill switch in WireGuard as well. So if for some reason it disconnects the VPN, you can kill the traffic going across using firewall rules to do that. So in this case, on this side, oops, gotta do sudo. Okay, so same thing here, except the only difference is the private keys are the local ones. The public keys are the flop. So this one is the public key for WG1. This is the public key for WG2. That's all there is to it. And then the endpoint are flopped as well. So this is pointing at this machine. This is pointing at this machine. So let's go ahead and bring it up. And we'll do WG2. There we go. And if I hadn't put that rule in for the SSH, I would have frozen right there. I would have froze right there because I wouldn't have been able to get my SSH to go any further. So if that happens to you, it's because you're missing this rule right here. All right, so okay, so both of them should be up. We'll give it a couple seconds here, and then I'll do a sudo again. All right, so, and that'll show you that there hasn't been any traffic yet. Nothing's going on because I haven't actually done anything, right? So, there we go. So if I ping, now I should show the handshake. And it has connected. So I can do the same thing here, going backwards. And I'm able to ping that side as well. So I guess the first thing I want to find out is, now I'm not through the tunnel, right? I mean, my SSH connection is going from my local machine to this host. So I'm not tunneled through it, but can I go through can I SSH from this box over to WG2? So let's find out. Looking good so far. Yep, all good. So I'm over on WG2, so that's working. I can tunnel through. That was not working before either, so I have fixed that problem as well. So next thing to find out here is how is the performance of, I guess I should set up maybe a comparison between this and OpenVPN. Maybe I'll do that down the road, but right now let's just see how much of a difference there is between going through the VPN and not going through the VPN. Now, this is because both of these virtual machines are inside of the virtual machine. Both virtual machines are inside the same server. They're going to go memory to memory, so they should be really fast. So yeah, let's find out. Now I've installed iperf3, and we'll make this guy the server. And then we'll do iperf3, and we'll make him the client, and we'll point it to over the tunnel. It's about 3.5 gigabits per second. Yeah, I mean, this is flipping it around pretty fast, and the amount of data I'm sending is trivial. I mean, it's not sending a whole bunch of data. It's not sending a lot. Okay, so I'm going to leave that up right where it is, and this time I'm going to use the outside address, and we'll go to 115. So let's see what the difference is. So this is non-encrypted, non-VPN traffic. I can tell you right now, this is a lot faster than OpenVPN is. I mean, you might look at that and go, oh, 26 gigabytes a second, you're dropping to 3. Wow, that's a lot. Yeah, go try it with OpenVPN. You'll see it'll drop even a third beyond that. So not bad, not bad. A third, maybe even a quarter of that speed. So yeah, I mean, that's just personal experience with it. So one of the other shortcomings of WireGuard is that there isn't now OpenVPN, you can assign a user ID and a password, right? You can't do that on WireGuard. They are assuming that this is going to be done by third parties. So yeah, I mean, as long as you got the key, that's fine. You just have to make sure that the keys don't escape. I don't typically use passwords anyway in my internal network, so I use keys. I mean, I don't use passwords. I mean, that's kind of old and kind of dumb. If you want somebody to hack into your machine, use your passwords. What else? I guess we should try it the other way and see if there's any difference going across from. There shouldn't be, right? There shouldn't be. Well, let's see. Let's put this guy up and let's bring this one down. Now, one thing, this is also an IP, I think. Is this using, doesn't say if it's IP or UDP. Don't know. I have to go look. I don't remember. But let's see what it is for. So it's about the same, 26, 27, maybe a little bit slower going that way. And then we'll try it over the VPN. Yeah, 3.4. It was about the same. 3.1, 3.8. Maybe a little quicker going that way. But yeah, not bad. Not bad. Pretty impressive performance-wise as far as I can see. I would have to now. iPerf 3 is not. It's not a good tool to use for looking at latency. All it's going to really give you is an idea of bandwidth. So don't. If you're thinking this is going to be a good, look at the interval, it's great. No, I don't look at that because this is not a good tool to measure latency. There's other tools that are much better than this one. But this is kind of a simple way of looking at it, at least from this standpoint, to get some idea of what the performance difference is. And then I would want to go load up a net benchmark and actually run it and then verify what the actual results are. So I think that's where I'm going to stop today. I got it working, and I got SSH to work. So, like I said, if you run into that problem where you're trying to configure and you're doing the WG quick up and all, one thing, I always leave out something, don't I? One thing I didn't do here. So I did put, let's do the IPA first. So you'll notice that it does create the endpoint. It's point to point, no ARP, up lower. 1420 is their MTU size. I'm going to go ahead and it should be the same on both sides. I didn't make any. Now you can adjust any of that stuff. There's settings in there for anything. So yeah, you can adjust things around the way you want. Also, I doubt there'll be a whole lot of information here. Yeah, but it will tell you that it received, and if there's any drop packets or anything, which I don't have any. So let's see what this one says. I would think that if this one had it, the other one would too, but nope, none so far. Pretty clean. But then it's memory to memory. It's not actually going through a network. So I think what I'm going to do is try to get this up on hardware. I'll probably have to do it on desktop though, which is okay. I have a couple of servers that I am running. I could set up, and I think what I'll do is I'll go back and do this on hardware with an actual desktop. And I think what I'm going to try to do is do it with a Mac OS, Windows, and a Linux desktop, and just see how it compares performance-wise. I want to go get a network benchmark and then see how things actually look, as far as latency, bandwidth utilization, and all that kind of stuff. So anyway, more work to do. So far, so good. It looks promising. But But again, you know, it's new, and so don't take this as a review to rush out and start using this in production. I wouldn't do that, not yet. Anyway, hope you enjoyed this video. Hope to see you again real soon, and bye for now.